So today we're going to disassemble an EcoSmart LED bulb and repair the insides of it. This one does not work. So the first thing we're going to do is we're going to cut the diffuser off. I've seen other people that have taken a knife blade and put it in there and then whacked it. In my experience, that can do a lot of damage to the insides of the bulb, that is, to the electronics that are in the bulb. So I prefer not to do that. What I'm going to do is I'm going to use one of two tools. I have a coping saw, which you can buy at your big box store if you don't already have one, and I have a small hacksaw. Either way, you want a reasonably fine blade, reasonably fine tooth blade. Although probably a regular hacksaw with 32 teeth per inch is probably fine. These are actually very fine and take a fair amount of time to get through the plastic, but it is a little easier to control. So, so today we're going to try the coping saw and see how that does. So we start with our bub, and we're just going to cut right at the seam. I don't know if you can see it on camera or not, but it's cutting through it fairly well. And I think we're pretty close to through it now. But what I don't want to do is cut all the way through with the blade at the same angle, because I believe in most cases, I guess all the cases I've seen, the electronics is down below the frame of the bulb, but you don't want to hit anything. So I'm going to just rotate the bulb slightly as I cut, so that I'm never cutting very deep into the bulb. Okay, we've now made one lap around the bulb, but I've intentionally not cut it terribly deep, just so I can We're getting pretty close. Okay, so now we're almost through. So I have a little bit more to cut right here. And one more piece right here. Now, please understand that I've done this very slowly for the purpose of the camera. You can actually cut through this much quicker than I did this time. So, but the idea is that we are going to repair the bulb, and then we're going to put the diffuser back on, and we're going to use a little super glue to reattach it after we clean it up with an X-Acto knife. All right. So this is the inside of the bulb, and what you can see is we have 9 LEDs. Those are the little yellow things, little yellow square things around the perimeter. And most likely, one of those has burned out. These bulbs are very, let's call it, inexpensively manufactured, and they don't, they run pretty hot. They're cool to the touch, compared to an incandescent bulb, but they do run pretty hot. And inside the diffuser, it's quite warm in here. So, and I think they're pushing them pretty hard on the current. That is the amount of current that flows through the device. So they're asking a lot of these LEDs, and sometimes more often than I'd like. For bulbs that are supposed to last 1,000,000 years, they just freaking don't. So we're going to find out which one is bad, what we're going to do, and you got to pay attention to this, because if you have shaky hands or you're stupid, don't do this. Don't do this. We're going to plug it into a socket. We're going to turn the power on, and we're going to individually short out each of these LEDs. Because the way this thing is manufactured, or the way it's designed, the LEDs are all in series. They're like Christmas tree lights. So the end of one is attached to the beginning of the next one, and the end of that one's connected to the beginning of the next one, and so forth, all the way around the string, so that if one of them burns out, the whole bulb quits. Which and then you go down to the store and you pay another $15 for a box or whatever, But I'm cheap and reasonably handy, so I prefer to repair them myself. So that's what we're going to do. So we're going to plug this thing in. We're going to come up with a device, which I'll get to in a second, that's going to individually short out each of these parts and see which one is the bad one. So I will plug it in and then get back to you. Alright, what I have here is just a fixture that I use for illuminating things. It's got a little squeeze clip on it, but it doesn't matter. You can use anything you want that's got a light socket and a place to plug it in. So what we're going to do is we're going to first plug in a bulb that works, just to make sure we know which switch position is on, and then we're going to turn it off, unplug it, and then plug the socket under test into the fixture, into the lamp, turn it back on, and then we're going to continue our testing. So here's a bulb, presumably works. We're going to plug it in to the socket, and then we're going to plug the socket in. We're going to plug the lamp. We're going to plug it into the lamp, and then plug the lamp into power. So Okay, it's on. We don't want it on. We want to turn it off. So then we're going to unplug it. We're going to remove the bulb and put the bulb someplace where you won't think it's one of the bad ones and cut it open. That's the voice of experience talking. So now we're going to plug the bad one in. I'm going to plug the lamp back into the power, and we're going to turn it on. All right, it does not work. So what I have is I have insulated a pair of tweezers. All right, used some duct tape, and I would recommend that you wear, preferably nitrile gloves, or at least latex gloves if you don't have an allergy. And for this next part, because what we're going to do is we are going to take this tweezer and we are going to individually short out each of the LEDs in turn to see if we can, to basically bypass it. Because in a lot of cases, but not this case, in a lot of cases, the LED will have a burn mark on it that will indicate pretty easily which one is bad. I don't see anything. If you have a microscope, which I actually do, if you have a microscope, you should take a look first so you can try to make an educated guess as to which one is bad. Actually, I'm going to do that right now. Well, unfortunately, the microscope doesn't provide any clues. You can see that I put a black dot right there. That's diode D1 if you look at it very closely. And then the next one is D2 and 3 and 4 up through 9. So what we're going to do is we're going to individually short out each of the LEDs and see if that fixes it. So I've screwed it back in, or I am doing that, and then turning the power on. So, okay, little tip here, my insulated pliers, my insulated tweezers aren't insulated at the end, and I'm holding this thing in my hand and I got a little sting from the end of the tweezer. So wear gloves, be smart. Now I'm going to fix my tweezers. Alright, so I've repaired my tweezer now so that it hopefully won't get me. And now I'm going to go back to working on my light. So we're going to short out D1, and it is completely coincidental that shorting this out fixed it. If I had shorted out D2, you can see nothing really happens, and D3 and D4, so on. Nothing happens, but I go back to the bad one, short it out, and that fixes it. So D1, the one that I just happened to mark, and I'm telling you, this was totally random. It wasn't random at all, actually. It was, let me see if I can zoom in. I guess that's as far as I can go. But anyway, if you open one of these up, you'll see that the diodes are marked D1 through D9, and it just so happened that D1 was the bad one. So we're going to turn the power off and then remove the bulb, remove the assembly, and we're going to take the LED off and jump across it to repair the bulb. Now I don't know what I can do as far as repairing the bulb is concerned. I have a microscope, but I don't have the means to photograph through it. So what I'm going to do is I'm going to go ahead and repair the bad one, and I will show you in some detail what I've done. So the sequence of events is going to be, I'm going to put this into a vise so that it's stable, and then I'm going to take a pair of dikes and cut the LED off. You know, there was no need for a lot of finesse. This is a Teflon substrate with an aluminum backing for heat dissipation, because the aluminum on the back of this PC board is attached to an aluminum shell around the inside of this bulb, and you can actually see that you can remove this. You can remove the bulb assembly, the LED assembly, because it's really just crimped in 3 places with 3 little crimp things, 1, 2, and 3, and then this assembly connects to the printed circuit board underneath by these 2 friction type contacts. So if you wanted to take it out, you could. I don't see any reason to. Like I said, all the electronics, the DC to DC converter and the current setting resistors and stuff, all that is underneath. And unfortunately, it's not easy to get to. I have torn up a couple of bulbs trying to get to it, because a better way to do this would be to jump out the LED that's bad, and then change the current setting resistors to limit the current through the diode array. Because what's happening on these bulbs is that the current is set so high that these things are being run at maximum power and at maximum heat. And because the manufacturers don't want these things to last a lifetime. They should. They actually should last a lifetime. And in my next video, what I may do is, instead of jumping this I may try putting chip resistors in its place and limiting the current that way, and see if we can make these bulbs last longer. So stay tuned for part 2. So in the meantime, I'm going to cut this, like I said, I'm going to use a pair of dikes and cut that LED out, and then I'll come back and show you what it looks like before I connect the wire. So here's the result of the first step. I took these cutters and basically just squeezed the LED between them, and this is the yellow lens for the LED, and here is the LED itself. It's this one. Man. Hopefully if you are doing this on a computer, you can zoom in and see, because I'm having trouble getting this thing to zoom without blurring. But where is it? It's right here. Okay. And if you look at it closely, you can see there's a diode in there. Now what I'm going to do, the next step, is I'm going to cut that diode off and start to expose the pads to which it's soldered, and then we're going to solder a wire across it. So there used to be a diode between those 2 pads, and it actually doesn't matter whether the diode is there or not, because what you want to do, that shiny stuff there is conductive, and it will take solder very nicely. So right now I have my soldering iron heating up, and I'm going to solder a wire across it. And again, because I don't have the means to photograph me actually soldering it. I'll show you the result once I'm done. It is really easy to do. Here's the results of the first step. What I did was I applied a little bit of flux. Now solder, regular electrical solder, comes with flux in it, but you can actually buy flux, which actually does a better job. And I had a little bottle because I do electronics work here, but it's not absolutely required. So what I did was I took the exposed pads that you saw a second ago, and I just basically tinned them, which is I put an iron to it, heated it up to each of them in turn, heated it up, and then applied a little bit of solder. Now what I'm going to do now is do exactly what I said before, which is I'm going to take a piece of wire. Actually, I'll show it to you. All right, what I decided to do instead of cutting a strand off was, because I have wire that's pretty small, I just went ahead and took the end of it that I had shown you a minute ago, and I just bridged it across the LED and soldered the whole thing. So I'm going to cut that wire off so that leaving just the bridge across the I'm going to cut that wire off so that leave just the bridge across the LED contacts, and then we'll fire it up and see what happens. And this is what it looks like afterward. It's right there. Hopefully you'll be able to zoom in with whatever your device is. So that's done, and then the next step is optional, but I like to do it. Is to clean, because I used flux, and even if you just use regular solder that has flux in it, it's going to be kind of brown, and flux by its nature is mildly corrosive. That's the point of it. The flux removes the oxidation from in this case, the contacts that we were using, that we were soldering to, and it does it by a chemical reaction. So we're going to clean that up and then put it into the socket and see if we've fixed it. Now what I'm using to do the flux cleaning is isopropyl alcohol. Trichlor works much better, but the OSHA police tend to come to your door if you use that. I long for I don't know if I long for them, but I miss the good old days of the 70s. So anyway, so here's the connection that has been cleaned, and basically I just used a Q-tip and some isopropyl alcohol and just scrubbed it until it looked pretty good, and that's good enough. So now we'll plug it in and see if we have fixed it. So here I am plugging it in. Zoom back out. Alright, and power on. There we go. So if you can now count the LEDs. You can see that we have 8 of them where we used to have 9, and life is good. So now we're going to glue the diffuser back on, and we will have a repaired LED bulb, EcoSmart style. So I took the opportunity to blow the bulb out, blow the diffuser out, and so now the next step is to glue it back together. But you know what I think I'm going to do is I was thinking about cutting some little air holes in here, actually melting them with my soldering iron just to let some of the heat out, because I think that would go a long way toward improving the life of the bulb, is just to make the thing, you can reduce the current that the LEDs are consuming, or that are coursing through the LEDs, and you can also reduce the heat. And so reducing the LED current is going to be part 2, and then I may in part two play around with cutting some air holes in here, because once the thing is in a socket, you can't really see it, but it'll make the bulb a lot happier. So I'm going to glue this down, and I'll show you how I do it, and then we'll see what happens. So I'm going to trim this surface to try to make it pretty even, and then I'll do the same thing to the diffuser, and then we'll apply some glue. I'm not sure what I'm going to apply yet. I don't know if Loctite, super glue will work or not. So when you're cutting, always cut away from you. This thing is slipping off and hitting my fingers, even pushing away from me. So be careful. So you can see that the diffuser was originally bonded down inside here, so it would have been very difficult to get this loose by cutting. I mean, by beating it with a hammer on a knife blade. So this actually looks pretty good. So it's looks pretty decent. It would have been a lot better if we'd used a bandsaw to cut it, but you can see that if we hold it sideways, you can see that I could not have cut all the way through because the components stuck up above where I was cutting. So I would have wound up cutting into that stuff, which I obviously didn't want to do. I'm going to mix up a batch of JB Weld epoxy. It's available at your local big box store. It's a high-strength epoxy, and it's not really necessary for this job. I mean, you can probably use a 15-minute epoxy because the strength should not be a big deal. But it is what I have. So I'm going to mix up a fairly generous amount and glue the diffuser back onto the bulb assembly. And the bad news is that it takes about 4 to 6 hours for this stuff to cure. But the good news is it isn't going to come apart again. I mean, unless you cut it. So so here we are mixing. Epoxy is not terribly friendly to skin. If you've used enough epoxy in your life, as I have, you can develop there is a statistically significant number of people who, with adequate repeated exposure to epoxy, will develop a sensitivity to it. And it's a skin sensitivity. You can read it yourself. I'm not going to give you any medical advice. So I've mixed up enough here for a couple of light bulbs, so maybe I probably should have repaired more than one. But it is what it is. And so far I've managed to, with one small exception somewhere, I've managed to keep it off of my skin. So here we go. apply it fairly generously. Obviously you want to keep it away from the LEDs themselves. It's hard to pay attention to what's on the screen and while doing this. It's a little stinky. Smells kind of fishy. A lot of epoxies smell like that. So it might be a good idea to do it outside or in a well-ventilated location. I'll have to learn how to speed up this video like people do the Charlie Chaplin kind of deal. Alright, so there we go, and we have the diffuser. Now what I'm going to do is set this aside for, say, 6 hours and see how it looks. The good news is that when you put this into a socket, you won't see this seam. So there we go. I'll clean this up a little bit off camera. You can clean it with lacquer thinner or acetone, or you can just wipe it down with a rag if that's your choice. Or you can leave it as is if that's your choice. You know, once it's in the socket, you won't be able to see it. So that's pretty much it. Once the epoxy is cured, I will plug it back in and verify that it works. And with that, I hope you are happy with what you've seen here. If you have any questions, please don't hesitate to ask. Leave a comment as you see fit. So thank you very much. And you can see it's already holding fairly well.